3D print. 3D printing is a great thing to know and understand, but you're pretty much very limited to what you can do if you can only 3D print. I'm trying to ignite a little spark into CAD, okay, so you guys can move towards design. Okay, Fusion 360, look up some videos. I have a name for you guys. Whenever you go to YouTube, the moment you type in Fusion 360, this great guy will come up, Lars Christensen or something like that. His name is something like that. He's great. He has his own class free on YouTube from step 1 all the way through. Fusion 360 has a step-by-step thing. Great software. It doesn't only have modeling, it also has sculpting and a whole bunch of other stuff. So if you're into arts, there's different type of modeling. I'm not going to get into that. This is a different class, different thing. Just understand that 3D printers are only a tool. Okay? It's not the main thing. You can't create anything out of a 3D printer. It will only create what's been given to it, which is a model. Okay? All right, now, I keep saying model, file type. What do I mean by that? For you to be able to 3D print, you need to produce from a CAD software this file type. STL. Now, this is very important to know. This is the file type that you need to be able to 3D print. Okay, to be able to go into a slicer. This file type goes into the slicer. Okay, it's an extension. You can name it whatever you want. You can name it house.stl. You know, whatever the name is. .stl is the extension, the file type. That file type is what you need to input into a slicer, which I'm going to talk about what a slicer is in a minute. Okay, so this right here, this is an STL that was imported into this slicing software. And I'm going to explain why it's called slicing and this whole stuff. Okay, just very important name, STL. Remember that STL. That you must know. Say you don't know CAD, you don't know how to design, and that takes a whole learning curve in itself. That takes a while. Okay, you can't learn how to be, you know, a CAD professional in a weekend or in a month or even 2. Okay, it takes a little while, and you got to build up. So a lot of people, what they have is an open source library. Who likes open source? No, people not for open source. Free stuff, guys. Come on. Okay, open source. So there's a lot of places where you can go, and just engineers and designers upload their designs for free. Okay, there's certain websites you can ask for somebody to be designed for you, and people just, I'm not sure why, they just spend extra time for you. One of the most famous ones, where you guys will mostly go, it's Thingiverse. Okay, Thing with an I and then verse. Thingiverse, right there, perfect. I'm gonna write this on the board. This is for you. This is only for you guys to browse through whenever you need to 3D print anything at all. Is there just STL? It's a library, a ginormous website. Libraries with STLs. A lot of people never need adapters for certain things. They'll just type in what they need, and somebody has already designed. There's millions of files on here and growing. What happened?
So we can use it as boilerplate.
What do you
design it?
Boilerplate? I don't understand.
Oh yeah, that's I mean like as a template.
Oh yeah, no, you can just use the file. You can take it for whatever you might need it to. Like let's say you're trying to design a phone case. Okay, you wanted a phone case for your phone because 3D printing is cool. And you don't know how to use CAD. You come in here, you type in phone case, and there you go. You have a whole bunch of pictures, people walking you through steps, settings to put in, and all this stuff totally works. People have tested it before. Okay? Eventually, the best case scenario is for you to learn how to use CAD software, because then you can customize it. You can make it your own. You can add your name on it. That guy probably has his name on it. Maybe you don't like Iron Man or whatever that is. Iron Man, I think. Yeah, and you know, so keep, you know, CAD is the main tool. Okay, great website, Thingiverse. That's where you usually are going to be going until you understand a little bit of design. Thingiverse, very important. Can you guys kind of see the board back there? I know it's a little, yeah? Can you guys see this stuff? Okay. Slicer, okay? There's some different types. The one we'll usually be using, the one we do use here is called Cura. That's the name of the software that we do use. There's a lot of different other ones, okay? These are open source. There's Simplify 3D. That's a very also common one, very famous one. Okay, a lot of people, those are kind of the top 2. Cura is made by Ultimaker, the company that made this 3D printer. However, Cura works with every other printer. It's open source. You can customize it to your printer. All you have to define is kind of what type of coordinate system it works with. Okay, this is like a Cartesian coordinate system. You guys familiar with coordinate systems? Delta coordinate systems?
What other coordinate systems?
Just usually the most common two is just the Cartesian and the delta coordinate system. Delta is kind of like a cylindrical thing. So those are kind of usually delta coordinate system or delta style 3D printers are very high in the z-axis to print stuff like this. Like this was printed on a delta coordinate system type 3D printer, a delta 3D printer, and so was the Eiffel Tower over there. That was also printed on delta coordinate system, which is basically you just get an advantage of the z. Cartesian is just big envelope. You can print big stuff in it. Okay, usually like when you want to print stuff like what I had up here, you'd need a printer like a Cartesian printer. Okay, like this is usually a standard printer. You need an STL file to work with a slicer. Where you produce the STL file from? From a CAD software. You literally export as an STL file. That's what you need to 3D print. A slicer can only read STL file. Also, they read object files, .obj. The most common one, you're always going to hear people saying STL. That's like the international file extension type for 3D printing. People are going to say, well, you have an STL. That's the only thing you need to be able to 3D print. People don't have 3D printers. They have stuff called tech hubs, okay, or like 3D hubs. And usually what they do is if you have a file, you need a 3D printed, you can't afford a 3D printer, you can pay them like 20 bucks, 10 bucks, and they'll, depending on the weight of whatever you're printing, and they'll print it for you. And they'll ask you, do you have an STL file? If not, well, do you need a designer? Well, it's like a whole business. They'll design whatever you want, they'll create an STL file for you. If you have an STL file you just need to print, you can send it to them, they'll print it for you. Okay, we're gonna walk through all this stuff. Just I'm letting you know resources in case you're ever out of Berkeley Community College and you need a 3D printer. Okay, there's other resources. You don't always need to buy a 3D printer. You don't always need to design. Okay, this is like a huge thing and it's been moving really fast. Okay, there's different type of 3D printers. We're gonna get into that in a little bit. Okay, I want to talk a little bit about the slicer now. We go to Thingiverse, we pick any file we want. Okay, this is just me walking through real quick how to download something in Thingiverse. You'll pick whatever you want. Let's pick something that's okay. Well, I'm gonna work with the file that I have because I like that file. Kind of explains what I'm talking. This is a phone case for a Galaxy, I think, or something like that. You go into Thing Files. Literally, you just scroll down. This is for you. This is not on anything. This is just extra for you to know. Okay, you'll scroll down. There's a lot of stuff, comments. You know, how many people collected, how many people made it. And under Thing Files, you don't need to have an account or anything. You just go on it and you click onto whatever you want, whatever file you want, and you just click on it. Okay, this is like a sketch. I think this is the actual CAD file, a SketchUp file. Over here, this is an STL. You see, it's an STL. Click on the STL. Once you download it, you see I don't use Macs, so I'm kind of struggling a little bit here. Oh, there's pictures here. Okay, here, DC White House. You just grab the file and you drop it into my slicer. Okay, which in this case is here. I just literally grab and drop. The file will come up just like this. Okay, this is where we start. This is what you really need to 3D print. This is step one. Step two is going to walk you through the print. Okay, this is when you need to really kind of pay attention. The slicer file, you grab the STL, drag and drop. It goes right into there. That's kind of your work envelope. This is like okay, different coordinates you have. The bigger the printer is, the bigger the whole envelope will look into there. I can zoom in a little bit. Okay, right there. So that's how big my file is right now in relation to this envelope that I have in here. I selected the printer, Cura Ultimaker 2. That's the one we have right here. Okay, if you have a bigger one, the Z will increase, the Y and the X and the Y will increase, depending on whatever you have. That's your work envelope, which is very important to define which printer you have. Okay, you can have multiple 3D printers, like if you have 4 of them, but you only need one slicer. Okay, you can just select whichever printer you want. The work envelope matters because if you have something that's bigger, the whole file is bigger. This guy is dumb enough that he'll try to print that. Okay, so if you tell it, okay, move to here, it will actually try to move this, which is what we call kind of the hot end. It will try to go all the way over here. You'll hear it crashing in itself until in steps it reaches all the way over here. So yeah, there's different type of 3D printers. Okay, SLAs, FDM is kind of the most popular one. FDM is the one that prints with this stuff. Okay, have you guys seen this stuff before? This is kind of what made this guy. It's filaments. This is what we call filaments. This is the plastic. Okay, it comes into rolls, into filament, you know, into these guys. And it's literally, let me see if I can get something out of here. It's a film, it's a filament, okay? That's what we call a filament. And this kind of goes, this is very simple. 3D printers are very simple. There's nothing to them. They look very fancy, very complicated. I promise. All there is 4 stepper motors. Who knows what a stepper motor is? Okay. A stepper motor is a motor that moves in steps. It's a stepper motor. Okay. Again, anything in engineering, you know, look at the name. It's literally what it is. Okay. It just moves. It pulls on it step by step. Very fine steps. That's why we can have very high accuracy. That's why we can get stuff this accurate. You can look at this line. You know, it used to be hard to get this. And this is actually kind of low quality compared to what 3D printers can do. Okay? So all it does is pulls on this guy all the way till the hot end, and it melts it, and then it will just 3D print the model you want. And I'm going to explain this in more detail when we get to 3D printing. I want to cover this. I'm just giving you like a basic idea of what's going on here. It's like a hot glue gun. Who's used hot glue gun before? Yeah? A lot of us? Okay, hot glue guns. Literally you take the glue stick and it melts it, and then you just literally pours it down exactly wherever you want. That's exactly what a 3D printer is. Okay? Except just much finer point. Okay? This printer, work envelope, very important. We get onto here. Now I'm going to be messing a lot with the screen. Okay, first thing you're going to see once you drop the file. Let me zoom in a little bit. Okay, first thing you get once you get into the file is literally what it looks like. Now to work with this, because sometimes you can have more than one file. You don't always want to 3D print only one object. I could put 3, 5 objects into there. So for you to edit or do anything with any file, you have to click on the file. Once you click on it, you see how these guys kind of activate it on the left hand. Okay, those are kind of your basic settings for to move it, scale it, or whatever you got to do. Okay, so if you go over here, this is kind of translating it. It's moving. You can move by exact dimensions, but if you're defining millimeters, I could just say go 5 millimeters positive. That kind of can go to the right. I can do 10 millimeters, right? And I can keep them. You know, I can just change that, and I can change it to whatever I want in relation to an absolute position. Okay, so I can do that 50 millimeters, and I'll go all the way over there. Yes?
Why would you need to translate something that was...
Because sometimes what if you need to print multiple objects? You want to fit them all in. You know what I'm saying? And I honestly usually never use these dimensions up here. You can just grab these arrows, okay, and you can just pull on them in whichever direction you want to go to. And then you can just pull onto the front. And or you can just, you see when it's grayed out? That means when you look at it, let me see how this guy works over here. There we go. When you look at it, it's really kind of exceeding. See how it's kind of, here, we go in the back. This little gray area, you can't be in there. There's a little hair that's in there. So that's not good. Whenever it's like a highlighted, whenever you see hatchings on it, that means you're out of your perimeter. Okay, can't print into there. Okay. All right. Next thing up is scaling. Okay, so what do I mean by that? Let's say I work in an architectural department or whatever, and I need to build a full-size room and up to detail, or like a building, okay, the exterior of a building, and you're doing this for an actual architectural job that's going to get built. However, you need to show this to the investor, and you want him to look at something. Well, you actually build everything up to scale, and you reduce the scale in here, okay? Or vice versa. Let's say you're working on something small, related to the medical field, and you want to show, I don't know, the only thing I know in medical field is a cell. You want to show what a cell looks like. You know, you can scale that up. Okay, and it works that way. And usually, you see this where it says uniform scaling? That's usually checked. Usually you do not want to mess with that. So what that does is, like, let's say I want to increase it to 110%. I just type in 110%. All of it uniformly goes up. Can you guys kind of see that in the background? I know it's kind of tough to see. I don't know why. I guess the smart board is messing around with me a little bit. There you go. Actually, let me. Oh, I scaled it a little too much. I don't have a mouse. Whenever you deal with 3D printing or CAD, you always want a mouse. Okay, so I resetted it. Let me try to move this guy up here. You guys can kind of see what's going on. Okay, so if I go like to 120%, it scales everything uniformly. Okay, now if I uncheck this uniform scaling, and I can go only like on my y-axis. By the way, on 3D printers, x-axis is right to left. Okay, y-axis is front to back, and z is up. Okay. Yeah. Let's say I want to increase this to 150%. That'll just make the whole thing a little wider. Let me see, go more drastically so you guys may be able to see that. You see, I just increased my Y all the way in. So now it looks like almost like a little film of some sort. So usually you don't want that. Okay, usually unless you messed up on the software somehow and you're trying to compensate for whatever you did. Sometimes it's useful whenever like you have a part and it's the right part, but it can't fit in a certain position, like it's a fitting problem, you just needed your Y to shrink a little bit, you would use this. That's what you would do. And just like in any plastics, usually, yes, somebody had a question? Okay, just like in plastics, usually whenever you go injection molding or anything and stuff, the plastic does shrink. Okay, and so in here, okay, even if you do print, stuff do shrink. Okay, it's not by a lot, it really isn't, but stuff does shrink. So if you're working on super detailed stuff, you need to take that into account. Okay, that's just extra I'm giving you guys for you to know. Okay, oops, not here. Rotate. You need to rotate your item. Okay, sometimes you want the front to be facing forward, the back. Sometimes it doesn't really matter. Okay, other times it does. Like if you're trying to fit something that looks like an L, and you have multiple of them, you might want to use that. So what you do is you can either grab, well, usually yeah. It's kind of hard to see at first unless you kind of look at it kind of straightforward. Okay, so you can kind of see it's like each one represents like an axis you'll turn around. Okay, you'll turn around the y-axis, the x-axis, or the z-axis, and it'll rotate around that axis. So in this case, so yeah, and it's increments of 15 degrees. Okay, you can rotate like by a degree. I think there's a way, I forgot, there's a way to do that. I think you can either click on it or go into the actual settings of the software. When it comes right off the package, it's increments of 15, okay? That's all you can do. So you can go up to like 90, 180, whatever you might need. Okay, there's one more, which is mirror. It kind of mirrors the stuff for you. You know, instead of you flipping, 180 degrees, if you just need like 180, it just mirrors it for you. Okay, so that's kind of an easier way to go. All right, that's kind of the basic settings of how to deal with the file. If you have multiple files, you can do that. Just drop both of them in. They'll try to fit. You can scale, rotate, whatever you need to do. Okay. Now, this is kind of the hard part. Okay? I'm gonna throw a lot of terms at you, a lot of details at you. This is what really defines the print. This is just how to move and put it around. This is what controls the quality of the print, the time of the print. Okay, the different materials will require different temperatures, all this stuff. I'm gonna go through that as well. Okay. Layer heights. Okay, what does that even mean? What is a layer height? Remember what I said? What does the slicer do? Slices. Okay, slices the item into different layers. How big is each layer? That's what the layer height is. Okay. The higher the layer height, what do you think? The higher the quality or the lower the quality? The bigger the number.
Lower quality.
The lower quality, right? Because you'll see a lot of steps. The smaller the layer is, the less steps you'll see. Like you really can't see each line in here. Okay. Sometimes you can have it to use the really visible. I can't find anything right now. Doesn't matter. Okay. So the higher the number, the lower the quality. That's what defines the quality of the print. Okay. Your layer height. Very important. Usually, printers can only hold down to like a specific layer height. Usually, it's about 50 to 200 microns. Microns, again, 200 microns will be 0.2 millimeters. 0.2 millimeters, that's kind of what you're going to be working with. Usually, whenever you just want to wrap prototype stuff. Okay, that's you will go all the way up here. You'll just roll this guy over. That'd be 0.2 millimeters. It says faster prints because each layer is so much thicker. The printer only has to go around it once. So let's say I'm trying to print a circle. Okay, I'm going to just go a little bit of how this printer works. Yeah, I'm going to work just on this part. What the printer does, we're going to explain later where this stuff comes from and how it comes there. But think about it. What the printer really does is just melts plastic. Okay, and it just moves in 3 axes. So it's the, X, Y, and Z. And it just literally, if I'm trying to make a circle, it'll just do this. It'll do, if I'm trying to do a circle that's a millimeter in height. Okay, if I have it set at 200 microns each layer, and it's only like one wall, assume it's literally a single line, it'll go around once, and then it steps up by 0.2 millimeters. Okay, and then it prints another one. We're already at 0.4, and does 5 of these. By that, we're already at 1 millimeter. Okay, 5 of those, and then it's done. But you see how because the layer height is higher, it took less steps, which is why the print would be faster. All right, so layer height defines the quality of the 3D print. So you want a high quality, you get a lower layer height. You want to kind of just to test it, just to see what it looks like, and if it works, you put a higher layer height. Usually the sweet spot is 0.1 millimeters. That's like if you want like a higher quality. If you want a fast print, you go to 0.2. Okay?
Can you go lower than 0.1?
Yes, you can. In this printer, you can go all the way down to 50 microns, so 0.05 millimeters. That takes super long while, but you get beautiful prints.
Yeah.
Okay, some printers can't handle that. Usually, like cheaper printers can handle it down to 100 microns, so 0.1 millimeter. Infill. What does infill means? The 3D printer never prints everything 100% solid unless you want it to. Okay, because it's a huge waste of material, and you really don't need that. Some of you might argue strength. Well, what about strength? You know, if it's 100% solid, I'm like, it's a solid print. It's hard to break. It's going to be under stress. Sure, you're probably right, but it gets to a point where usually right about 30, max 50% infill is as much as you want. That will almost provide nothing more. Like the other 50% will provide nothing but more time to almost no strength. So right about 30% is where the curve started looking like it's starting to flatten down to when it comes to strength. Okay, does that make sense a little bit? So usually you want to be between 10, minimum of 10. You don't want any lower than 10, to all the way 30. Okay, and I'm going to explain other instances that will need 100%. But what am I talking about? What is infill? Right? Well, that doesn't even make any sense. So let me walk you through here for a second. I have it at 20% infill. Okay, I'm gonna just finish setting up, and I'm just gonna actually click on prepare. Okay, I have a 20% infill. I'm going to click on prepare. Bottom right, can you guys see that? There's a printer in the way. Bottom right is a button that says prepare. So you see how it says starting slice? It's slicing. Now, it gives exact time how long this thing will take. It tells exactly how long it's going to take. This little guy right here will take 11 hours. That's how long it will take to print at 200 microns. So basically, the lowest quality you usually want with about 20% infill will take 11 hours, 3D print. So, huge feature that you will need to look at. Up top right over here, see it's solid view, that little drop down window. When I click over here, okay, there's different views. You have solid view, which is what we have right now. X-ray view just makes the thing kind of like clear, so you can see like into the background. I never use that. I guess it's for people that have something on the inside, like if you have like a little hole on the inside, you want to look at how that kind of works. Like if you want to put it on top of something, okay? But usually the one I want to take you to is where it says layer view. What layer view is, it breaks down everything the print is going to do into different layers, and each layer, each type has like a different color. So if I open this, so, you know, like, okay, so helpers, which means support, I'm going to talk what that means in a second. Shells, I'm going to talk what shells are in a second. Infill, I want to look at the infill, the orange color. Okay. This right now, this print right here, has 287 layers. Okay, it broke down this print into 287 layers. Okay, so you can tell what the Z height is because if you multiply it by, you know, my 0.2, you can tell me later right there. But the coolest thing is you can actually drag down to go to specific layers. In the middle of this thing, this is 20% infill, it's not solid, right? So when I drag down into here, look at this inside. You guys kind of see there? You see how it's hatching? Like a whole bunch of lines hatching? Okay? That's what the infill looks like. And here I'm going to hand out a few things so you guys can kind of see all different infills on the inside of printers, what they look like. You guys can pass them around. Okay? That's what the infill is. You see how 20% is very, very dense? 20% is strong print. Okay? It's almost solid. You know, it's a lot. Usually you want to be within 10%. That's kind of the percentage you want to be in. Let's see, let me drag this over to 10%. Click on prepare. Also, you're going to see the time drop down. Okay, it was about 11 hours. Let's see how much it's now. 8 hours. Okay, so the biggest two variables that control time on 3D printing is the layer height and the infill. Those are the two major variables that control time. So if you're in a rush and you need to get this thing going as fast as you can, reduce the infill, increase the layer height, that will give you the shortest time you can 3D print this guy. You see how it kind of expanded a little more now, it looks a little less, it's not as intense on the inside. You see this is 10%, 20% which would have another line right in the middle of each one. Okay, 50%, let me show you what 50% looks like. This is another visual. 50%. This is the newest version. Okay, before you used to just go 50 and it just automatically sizes it for you. I guess I can see pros and cons to this because I guess if you're changing a lot of stuff, you don't want it. Some computers actually crash. Okay, so I guess this is better because you adjust all you want. So this is 50. Okay, zoom into there. I don't even know, right? Okay. Guys, always get a mouse. This is what 50 looks like, okay? It actually did solid lines all the way across. Okay, it does them straight this way, then straight that way. Okay? That's why at the point you get to 50%, it might almost be better to go 100%, whatever you need. One would use 100%. Let's say I'm making a phone case. Okay, in the phone case I have very thin wall items. Okay? Thin walls, if you tell it 10%, it's gonna try to do that 10%. It'll do whatever you want it to do. So it'll do like a little line every, I don't know, every 10 millimeters it'll do like a little line, you know, every centimeter it'll do like a little line and then exit on the other end. And that's gonna give you like a flawed file. You're gonna have like gap, and it won't be structurally strong. Whenever you're dealing with thin walled stuff, you want it to be 100% infill. So if you're printing a phone case, you want it to be 100% infill. Does that make sense? Can you see why? Right? Because if it's a thin wall, it's gonna try to do some hatching on the inside, and it's only gonna happen every so often. So it'll either give you a failed print or like a low quality print. You can see stuff sticking out of the side. Okay, so whenever you're dealing with thin walled stuff, you want that to be 100% infill. Somebody else, like how to print something, and you don't want to go too much detail, you go into the recommended tab, you click layer height, infill, generate support. What does this guy mean? Okay, I'm going to walk you through what this guy means real quick. On 3D printing, the 3D print can only print, the 3D printer can only print it can only print from bottom to the top. It can print here and then go over to the bottom there, you know, kind of fix it. It just prints in layers, each layer once at a time. So what do you think the printer has to do if you're trying to print something that looks like this? Right? This is what we call an overhang. You're printing an object that looks like this. And you have to, whatever reason, print it this way. This would be the bed down here, right? What I mean, I keep saying the bed. What I mean by the bed is this piece right here, this platform. Okay, this right here is kind of where the print, everything bases off of. Okay, it just starts printing there up. That's the bed. Okay, so let's say you need to print this. Ideally, you never want any overhang. What's overhang is this. Let me do a different color. Overhang is this. This is overhang. Okay? Overhang. Overhang. What that means is there's nothing to build off of. So the printer is going to do is it's going to print this layer, this layer, this layer is going to keep going all the way up till it gets to here. When it gets to here, it's just going to print all the way across. It's going to be done. It's going to start over all the way across. And it's going to keep going. It doesn't know that on this planet we have gravity. Okay, and gravity is going to push this filament. They're not going to hold it. It's going to pull down. It's going to look like this. Okay, it's going to go like that. And it started creating something that looks like a spaghetti. It'll just pull over because once it pulls back, it's going to kind of pull it a little bit. And it'll make something that looks like a spaghetti. So the top is going to look like, we literally call it spaghetti. It will look like this, like a huge hair of filament. Okay, it's almost like an afro, 7 afro. Okay, so it looks like that all over the place. Okay, that's called overhang. Overhang is whenever you have something that you can't, there's no structure under it, nothing to do under it. So there's something ready for that, okay? And it's called support. It'll actually, it knows when it reads the file, it sees overhang. Over here, you can see overhang whenever I move. You see anything on the bottom that has red on it? Oops. You see that stuff? Oh, you see that, how it's yellow everywhere, but there's red, anything that has overhang, whatever doesn't have support under it, it's in red color. It recognizes where there's overhang. Okay? Does that make sense? Do you guys understand what the red part is? Yeah? Okay. So what it does there, it knows ahead of time, okay, when I start printing this file right here, when I start printing this guy, I know I'm gonna eventually need to put a line all the way up to whatever this X is. Okay, X equals whatever it might be. Okay? Whenever I get to here, up to this point, I'm gonna have overhang. And when I do that, I'm gonna fail. So ahead of time, it knows to generate support. What support is, it's like a very thick, very thin spaced piece of filament that has spacing between, usually, you know, it fuses every layer together because this is hot, you know, it's a piece of plastic. It goes right on top and it's super hot again, and they kind of just fuse together. And it keeps building layers just like that, one on top of the other one. Okay? one on top of the other one. It just kind of sticks. What it does with the support is that it actually makes a little gap. There's a little gap between the bottom and the stop. Okay? So the great thing about that is you can actually finish printing this guy on the top, right? You can successfully finish this guy. It looks like this. And you have support. Usually looks like a thick layer like this, and it's like a if you look at a top view, it will look like this. It's like a zigzag. Okay, and that's kind of the top view. What we look here. Here you just need straight lines. Okay. And what it does, since there's a little gap at the very top, this is not really the gap. It's not visually seen. You can't see it with your eyes. The filament does rest on top. It can create a straight line. Okay. If there's a bridge, the printer can move fast enough that it can bridge in between it. It doesn't always need to be 100% always over it. Okay, sometimes if you're building like a wall and it has like a little window in the middle, the printer can actually do that. Because it does, what it does is layer, layer, layer. I want to walk you through this. It's a little more advanced stuff. Okay, but once you're done printing, you can literally grab this with your hand and pull it out. Because the space, it's on purpose created the weakest point being right here. This is the weakest point, right here. So the moment in this right here, like there's a little gap usually, and if it's set, it's also the weak point. So once you grab this and you pull on it, it's gonna always, it's like paper, right? If you have like a little crack and you pull on the paper, it's always gonna snap right in that little shear or rip right in that middle. Does that make sense? It's on purpose creating that weak point so you can just rip that over. So if I click on generate support, of course it's more material, so it makes the print time longer. Right now we have 17 hours and a half. I want to click generate support. Click on prepare. It slices it again, including our support. So moving, let's go now since we have support into layer view. It's processing the layers for you. Okay, so let's show first are included, then material color. Let's go to line type. Do you see all the blue stuff? This has generating support everywhere. Okay, so the blue stuff are the supports. And increase the print time from, what did it say, 17? 17 to 21 hours. Okay, so look, as I go down, you see how the front all is inside? Now I have support. If I go down all the way to here, and you go to a top view, okay, can you guys kind of see that? Okay. It builds, oh, well, nice. Look, it left a little spacing in between it for you, so you can just rip it. Usually you need like pliers, like needle nose pliers, to get into tight spots. It really sucks, okay? That's part of the post-processing end, okay? Let me just give you, like, actually, let me step back for a second. I'm throwing too much information at you. 3D printing breaks into multiple steps, okay, to be able to 3D print. First one, as I mentioned first, is CAD. We need CAD. That's the first thing. 3D. That's just 3D, okay? CAD is the first step. From CAD, you need to go to a slicer software. Okay, you need an STL, and you go to a slicing software. Slicing. Okay, from the slicing, I'm going to walk over this. What it creates at the end is the file extension for the printer. Usually, it's .g-code. Okay, I'm going to talk about this. Don't worry about this for a second. I'm just kind of giving you like an idea of where we're going. Okay, so this. From here, we go straight to the 3D printer. Once you have this, we put it on a little SD card, you go to a 3D printer. After the 3D printer, what you're going to do is post-processing. That's the last step. Post-processing. Okay, post-processing is removing support. There's certain other steps to post-processing. We'll cover that, but the main part is usually just removing support. Okay. Now we go into custom. What custom means, you can actually control every little detail of what the printer is going to do. Okay. Quality, layer heights. You can actually type in whatever you want. Okay. We can make points 3. Okay. Now usually how that what did I write? -3. Sorry. 0.3. Okay. I can make it that. I can make each layer be that high. However, you got to think. There's certain capabilities the printer can, like you can't make if you don't have a bigger nozzle, which is what the printer prints from. Okay, the nozzle is the hot end that I keep talking about, where the printer prints from. I'm going to walk you through everything in the printer. Again, we're gonna set up a print together, but just know that the printer has what's called like a little brass piece. As it goes through here, it melts. This kind of looks a little sharper like this. It melts and then extrudes. This diameter over here, most commonly, 99% of the time, is 0.4 millimeters. That's the standard nozzle diameter for most printers. This number is important. You have to know what nozzle diameter you have. Okay? Let me know if I'm throwing too many numbers, too many terms at you. Okay? You didn't just roll the thing. So I'm going to move on from that. I'm going to keep this actually. Let's keep it at 0.1. And, okay. So now next thing I'm going to go into is shell. What is shell? What does that mean? Well, this new software has like a lot of custom settings. Okay. What a shell is, every print, I'm going to look at a top view of something. Let's say a square. Okay? Look at a square. This is a top view of just a standard square. Okay? The printer prints in layers. It goes like this. But everything has a thickness to it. Right? Like, I'm sure there's a few prints out there already. Okay. There's little guys. You guys have the little guys around? Okay, if you look at it, yeah, here we go. Okay. If you look at the edge, it's thicker. The wall is thick, right? But think, the nozzle is only 0.4 millimeters. So how many walls do you want? It'll print how many walls you want around it. Right now, if you only have one, this hole will be 0.4 millimeters. Okay? If you want like 3 walls, it will print 3 walls right around this. Of course, they don't look the space. They're like literally right next to each other. But my hand is not that accurate. Okay, so we'll print 3 walls. So the thickness here would be 1.2 millimeters, literally just mathematics, just addition. Okay, but why is that important? They never give you want 1 shell, 2 shells, 3 shells. Some other softwares do, but you have to input the type of nozzle you have. Over here, it's just a number. It's asking for how thick do you want it. So you can pass it around. Look at the side. That's called the wall or the shell. Okay, that walls at the edge. You can see that it's kind of open. The edges. Those are the kind of what we call the shell or the wall. And here they call it the shell, the wall thickness, but it's called the shell up top. So both terms work. Okay, it's the outer edge of the print. The more you have, the more sturdy it is on the outside. The less you have, the more fragile the print is. Okay, so the shell thickness depends on the nozzle. That's important to know. That's a fact. Okay, shell thickness or wall thickness, it depends on the nozzle. That's what defines. Because you can put 0.6, and it'll try to do 0.6, but it'll give you like a messed up, it'll try to make that, but it won't be able to because it can. The minimum layer, the minimum number that can extrude in a single line would be that thick, which is your 0.4. Okay, it'll try to do that if you tell it to do 0.6, but it won't be able to. Okay, unless you're working with a 0.2 millimeter, then you know that means 3 walls. That makes sense? Okay, and it gives you different variables. Like sometimes you want the top and the bottom to be thicker, but the sidewalls not so much, which is why I give you top and bottom thickness. Usually I keep them the same. I never had a case where I needed different thickness. Okay, look, infill pattern. And here in this one, look at that. Before they used to have it in the back of software, back end, which is where you define what type of infill. And here they have them all for you, right up here. Triangles, trihexagons, cubic, whatever you want, So it tells you what type of infill you want. So if I want to switch to triangles and make this thing maybe 10%, 20%, should be 10%. Okay, and I click on prepare. The inside infill now is going to look like triangles. Before, you used to have to go all the way back in the software to change that. So you see how it looks like triangles now on the inside. All this support looks like triangles. Okay, so you can control that. Again, it depends on like what you need. Okay, different infill. That's a whole different thing. Okay. We understand what infill is for? Just mess with percentages, that's usually what you want. Just say if you need something light, 10%, if you need something strong, 30%. So that's usually the average room you're going to be with it. Okay? Make sense? All right. Speed. Okay? Why do you argue? But why are you telling me what controls the print speed is the layer height and the infill? Well, I can control the speed of the print itself. The printer can move only so fast. Okay? There's 2 things that vary whenever you're going to change speed. Would be your feed rate. You guys know what feed rate means?
How much filament is feeding at one
Yes,
time?
like how much film is coming out, right? That's important depending on speed, right? So the printer can only melt so much so fast, right? And if you move faster than how much is melting, then you're gonna have under extrusions, right? You're gonna have lines that fade out, or the printer's not gonna work. You can never print too fast. However, if you print slow, usually when you adjust the speed, it adjusts the feed rate equally. You know, it compensates for it. But remember, you can only melt so much at a time. Okay, you can't put out, like, some printers can actually print all the way to 100 millimeters per second. Okay, right now this is 60 millimeters per second. That's kind of the average for this printer. That's actually kind of fast. For a while, but we're going to print this soon, hopefully. So usually just adjust this to 40. It'll standard be 60. Just adjust it to 40. That will increase the time. But I promise, it's okay to spend a little extra 2-3 hours for something that'll work than waiting 24 hours and then having something that failed and you waste all that filament. It's very frustrating when you wait a whole day and you come the next day to pick this thing up and just see the spaghetti all over the place. Okay? And okay, so travel. Okay. This is a new feature too. It says Z-Hub, when extraction is done, the fill plate is lowered, create a clearance between the nozzle. Okay, that's cool. So sometimes the printer ends, or the print ends, it just stops right at the top of the print. Right, so like if you're printing whatever, once it's done, it just stays right there. So the last end, the hot end usually stays right on top of the print. Okay? And if your thing cools down, it might solidify on the nozzle, and then it kind of grabs the nozzle, so when you pull it, it could cause damage or whatever. What this does is just kind of pulls down the whole thing, pulls down the bed so it's away from this. This already includes, like at the end of the G-code, which I'm going to explain what G-code is in a second, it just automatically goes home to its 0, 0, 0 position. Okay, home is whenever all axes are 0. Actually, home would be, in this instance, I think would be one of the back corner left, something like that. It depends. Different machines have different zeros. Okay, this guy goes all the way up to here. So I guess in this machine, this would be the 0. So I guess you could check that. It wouldn't hurt. So at the end, just it'll go back up. It'll increase some distance. Cooling. Okay. French cooling. What does that mean? Certain filaments need fans. Okay, it's different filaments work with different temperatures. Most common ones you're always going to be using are going to be PLA. Okay, that's the type of plastic. PLA is kind of what we have actually right here. This is it will state it. It will say it. Okay, PLA, and that's usually your go-to. It's the easiest to print. Why do you need to know this? Because different plastics will melt at different temperatures. Let me write just the main 3 ones that you kind of need to know. So let's say material, column, nozzle, temperature. So 2 things heat up on the 3D printer, okay? The nozzle, which is the hot end, and what kind of melts everything down, and the bed. Why is that important? Well, sometimes imagine if you have something very hot, and the moment there's something cold, it's going to solidify right away. That might cause, you don't want that because first, when stuff solidifies, remember it tends to shrink, plastic tends to shrink. So as you do that, as you build up layers, it might warp. It's going to warp your pen. So your print, instead of looking flat at the end of a print, it'll kind of look like it'll warp upwards on one edge, maybe on both edges. The whole thing could warp up. Okay, so that's why certain stuff we need the bed to also heat up. Okay, this usually PLA, which is the coldest material we'll be working with. Okay, PLA is kind of like the easiest, coldest material. The nozzle temperature is between 205 to 220 degrees Celsius. Okay, I'm not going to put Celsius. We always work in Celsius. Okay, metric, SI system. 200 degrees Celsius. You do not want to touch that. Okay, it'll burn you before you even know it. Okay, the bed on PLA, you really don't need. You don't need cooling. Okay, you don't need the bed to be hot. You can. Not all printers have a heated bed. That's a nice feature to have. It's an extra thing to have. Okay, the cheaper end printers don't have a heated bed. The bed you can control heating. That's why a lot of people just print PLA. So you don't need, but sometimes on this one, just keep it around 60. It's kind of like a nice spot, but you don't really need it. It's optional. It's optional. You don't really need that. ABS. ABS is another plastic. I'm sure you guys have heard of ABS before. Yes?
No.
You guys heard of ABS? A lot of stuff is made out of ABS. Yeah? You've heard of it? Okay. ABS. Hotter. It's hotter stuff. ABS usually prints between 220 to like 230. Oh, no, sorry. 235, 240. But I print all the way up to 250. Okay, I've had to take it up all the way up there. But the recommended stuff is between 220 to 235 degrees Celsius. ABS meant much hotter. But ABS shrinks a lot. Okay, it has a huge shrinkage. So you want the bed to be really hot, between 90 degrees to 100 degrees Celsius. So this bed right here, it's kind of very easy to bump into. Okay, a lot of this print is nice, kind of closes it in. Not all the printers do that. Sometimes the bed is right out there. I caught my forearm a lot of times. Okay, as you move something, look at something, it really catches you. It'll leave a scar. Try to avoid it. A huge new thing that's kind of working with, instead of ABS, replaces ABS. I'm gonna leave it like that, like this, because you could use it sometimes. There's cool features to ABS. PETG. Okay, PETG is also very, very, very strong, very durable material. The red hand that will going around. Yes, this is made out of PETG. Okay, very strong material. Very it's the whole point of people who use ABS is for strength. Okay, it's a strong material. Has some cool post-processing stuff. You can make it shiny. Okay, if you have like an acetone bath, you get a rag and put like acetone on top of it. It'll melt the layers. Acetone will kind of melt the ABS, and it'll kind of make them look nice and smooth and shiny. So it can look not 3D printed if you really treat it well. Okay, if you post-process it well. That's what you use ABS for. But if you're only looking for strength, PETG is the way to go. Okay, it doesn't have a strong scent to it. It's much stronger than ABS. It also prints very hot. It's also around the same temperature. Okay, that's around the same temperature. So PETG is the way to go. I wouldn't recommend using ABS. I almost never use ABS. That makes sense. Let's say you print, like you model something on CAD that looks like this. Okay, and you control what this angle is. Okay, whatever this is, whatever your angle is here, you can just vary that. You can put 50 degrees. You can go down to 30 degrees or all the way up to like 70 degrees and see how much it can handle. Every printer will handle differently. Some can actually usually go about 60, 50. You know, that's kind of the 50 is like a max. Like 50 degrees from your build plate, that's kind of like the max. Why does it work at all? Because remember, it won't go like a straight line up. That won't work. It'll just go down. What it does is it just goes layer by layer, and every time it just starts to lay a little bit deeper outside. Okay, it just goes a little bit offsets it a little bit, and that's how you get like a nice angle. But sometimes whenever you have too much of a steep angle, it'll try to go a little too far, and it'll just keep on doing something like this, and then the film will just droop down. So different printers have different angles that you start having support. So if you're printing this object, you always want to avoid having support. You don't want support. It's very hard to get rid of. It's a pain, you know, it sometimes gets stuck because that's easy to remove. Now, build plate adhesion, the last part, very important to this. Okay, somehow you need the bottom part to be stuck onto the build plate. You can't have it move. So a lot of times what I do, I add a little bit of glue stick. A little glue stick, the standard paper you guys use in the garden, put the stuff together. Okay, just put a little bit, like literally one layer, pull over the bed once it's heated up, and then this will help, you know, make the material stick onto the bed. You need that. Every print, I always do that. That's why the bed looks a little messed up. You guys can see like there's a whole bunch of stuff. It's not like a nice piece of glass. Can you guys see that? Yeah? So that's why. You always add like a little glue stick and go over the top. It's better to be safe than sorry. You don't want this happening to you after like a 20-hour print, okay? It'll not, you know, again, it's not pleasant after 24 hours. You just realize you wasted a whole bunch of material and a whole bunch of time to start over again. Okay, so whenever you doubt, should I have extra, go for the extra. Unless you know your printer. After a few times, you'll be able to know, okay, I can push it this far, I can do this much. Okay, that makes sense? So, also in the print itself, they actually give you build plate adhesion types. There's usually three types. Oh, there's a fourth, this curtain. Okay. So there's a brim, there's a wrap, and there's like no adhesion type. The most common one would be the brim. Brim is very important even to know. What the brim does is adds little layers. Let me demo this thing. So let's say I have a brim over here. I select the brim. It usually gives you, usually lets me know how thick I want it. I guess in the new software they took it out. Let's see what this looks like. Prepare. So you usually can define how thick you want it. I'm sure it's now they moved it to the back. So you can, in the back, you can handle, okay, when you click brim, you want it to be 0.8 millimeter, 0.5 millimeters. You don't want a lot. Usually you want a few more layers. If it's like a standard thing, like just a straight up cube, you don't want anything to it. You know it's going to be nothing. But if you're doing like what you were talking about, then yes, you want more adhesion. Add a brim. Yeah. So. So again, it's slicing now. I'll click prepare. So it's slicing the prints. Got it in the background. I'm going to show you what I mean by the prep. It's going to take a little while. The faster your computer. Again, some computers won't be able to handle this stuff. It might crash whenever you go into your layer view. It will usually work with everything else. Layer view might make your computer a little wonky. Okay, so if you look at the bottom here, okay, you see this extra stuff that it added at the bottom? Over. Right there. Actually, I don't even know. I can go to solid view. Oh, we don't have it in solid. No, we don't have it in solid view. Okay, so it's only layer view now. It's going to cross another view. Okay. So you see this? That's my brim. That's what's called a brim. So a brim is used for adhesion. That's actually on the outside to increase the surface area that the whole thing is being held onto or grabbed onto. Always add glue. That usually works. Okay. Preferably there's another brand that's like purplish, something like that. I don't remember what the name was. I'll show you guys. But whatever I have there, I always have some sort of glue there. Use that, okay? You don't want the print to come off. And also, if it does come off, sometimes it lifts off, that will also give you work. It'll work, okay? That's extra for you guys to know, okay? The main components of a 3D printer that you need to know that you're always going to be dealing with is the hot end, okay? The hot end is this guy over here. Let me see. Actually, let me just. Let me see. Okay. You see how this guy moves here on the top? I can move this along my y-axis, my x-axis. Different printers work differently. Sometimes the actual head goes up and down, as in the z-axis. In this printer, what happens is that the bed goes up and down, with a little has a screw, a threaded screw. Okay, you have one threaded screw, and this turns. As this turns, brings the bed up and down. Can you guys see that? So there's a stepper, there's a motor right back. Sorry, it's gonna be like the motor's guy. In the back right here, there's like a threaded rod, and that rod turns, and the bed itself has like a little nut, all right? And as the rod turns, it pushes the bed up and down. Okay, does that make sense? Okay, so that's the way this guy moves. And the most important part, the most crucial part out of 3D printing that you need to be accurately calibrated. Otherwise, you'll 100% have a failed print. Is the bed. You have to level the bed. There's no way around it. And it takes a while to be good at it. It really does. Some printers have an auto bed leveler. This one, unfortunately, does not. So you need to manually level it. I'm going to show you guys how. I'm going to walk you through step by step how to do it. It's very, very tedious at first. Whenever it's really off. This is usually, I'll try to always calibrate it for you guys. You don't need to level the bed every single print. Every 3 to 4 prints, usually you want to level the bed. Unless it's a really important print, you want to level the bed right on the spot. Okay? This one's been having some, again, this is not up to spec today, but we're going to try to get a print out of it. And yeah, so the bed is the most important part that you need to calibrate before you print to have a good quality print. Okay? So, leveling the bed, and then I'm going to show you guys how to switch filament. So first step to level the bed. I'm going to have to read you guys what this thing says. I wish you guys could see it. Okay, there's 3 options. The way this printer works is a little wheel. Okay, there's a little wheel here. You turn it right and left. It kind of toggles through the options. Okay, at the very first screen when you first turn it on, there's one that says print. Actually, okay, there's 3 screens. One that says print. The other one says build plate, I believe. No, material. Print, material, and maintenance. Okay. All these options we just messed around with can be overrode. You can override all of these through the printer. Okay. If I want to change the heat, if I want to change the speed, I can change that on the printer. I can override everything from here. Okay. Usually you don't want to do that unless you notice. Okay, as you're printing, you're like, oh, it needs to be a little hotter. Then yeah, you'll increase it a little bit. Oh, you need more feed rate. Yeah, you do it from here. Okay? So you can override that. Usually you don't want to do that. Okay? So we're gonna go under maintenance, because leveling the bed shouldn't be an everyday thing, although it's nothing wrong with doing it, just time consuming. Okay? So under maintenance, so again, wheel, toggles through the options, and once you want it, once you find the option, you just click on it. Okay? Now you're into a whole different other window. And top left says build plate, to the right says advanced, and the bottom says return, as in go back to where you were. Okay? Build plate is where we level the build plate. Advanced is we're just gonna have just like your like bed temperature, all this other stuff. Yeah, like what type of temperature you're using, the feed rate, all this other stuff. Okay? And so let's go under build plate. So when we go, the best thing about every printer you'll ever buy, usually, except for like the really cheap ones, like the $50-100, it will walk you through how to 3D print. It'll have like, it'll tell you, okay, first thing do this and do that. So if you get to forget or like get a little confused, it walks you through it. Okay. Build plate. The first thing it's going to tell you, okay, I'm going to walk you through how to do this thing. So you click on continue. When it tells you that, okay, it's going to go to 0. It's going to bring everything up to 0. So the 0 is going to go to the very back over here. See how there's a little space right now? I should never be doing this. See how I'm touching this guy right here? I would burn myself right now. Now, the very first step of this thing is half manual, half to the machine. Usually others are usually manual. Little knobs, okay? This is the kind of confusing part. I'm going to walk through the first one first. As I turn this, okay, it goes up, I think almost like 0.1 millimeter, something like that, 0.1, or maybe 50 microns, I'm not sure. Okay, so as you move this up and down, it brings the whole thing up and down. So the whole plate first goes up. And what you need to calibrate this is a very, very expensive piece of equipment that you should. The thickness of a piece of paper is the thickness you need, or the space that you need between the bed and the nozzle. That distance must be equals 1 paper. That's what it equals, okay? So you usually just kind of place this guy right in, all the way to the back. Okay, and I'm gonna kind of, after I do this, I'm gonna kind of have you guys come over here and kind of feel it. You need to feel this. I'm sorry, I'm gonna have to make like a line. I know it sucks, but it's tight, but we're gonna have to work with it. Okay, so right now it's very loose. One thing that usually a lot of people tend to do, I used to do it, you know, whenever you level the bed, sometimes people will rest their hands on the bed. This bed is like, it's very, okay, we're working with like 0.05, like 0.05 millimeter, 50 microns of tolerances, okay? So anything, any weight, extra weight, will shift the whole bed. You don't want your hand resting onto this. You see when I'm doing this, I'm literally having my hand outside and just sliding the paper in and out. See this? That's all I'm doing. Okay, just in and out. Oops, in and out, okay? And you want to move, the first step is to move this guy as you're moving in and out. Okay, yeah. I'm going to move this guy in and out until I find just to feel a little resistance on the paper. Okay? A little bit of resistance. Ooh, wow. Okay, now look, it's too tight now. It's holding onto the paper. And it's too tight. Sorry, that's going to happen a lot. Okay, so I go down a few more steps, a few more steps, a few more steps. Now I can move it in and out, but it feels a little stiff. Okay, you want to just, you barely want to feel like resistance. You want it like this. So I kind of want you to do it. So that's literally how careful I don't do it every single time. Okay, now the edge will do this the same exact thing. Okay. However, this I'm going to kind of have to talk about it because in here, this doesn't really move anything. Okay, it's manual. These front two are manual, and it looks like this kind of counterintuitive. And I just got to touch this page real quick. Okay. Okay. Who's ever heard righty-tighty, lefty-loosey? Yeah. Right? Turn to the right, gets tighter. Turn to the left, gets loose. It's actually the opposite here. It's a little bit confusing, okay? Because this is what happens, okay? You have your bed. This is where the print is, okay? And then right under this, you have like a little spring. Okay, well, we have it in the glass top, kind of, sort of. Okay, but just so you know, you have like a little spring. Okay, you have a spring that looks like this. This doesn't really look like spring, but a spring will kind of look very confusing, so let's assume this is a spring. It looks more like a screw. And over here, we have another spring, right? And the very top here, we have like a little nut. You guys know what a nut is? Right?
Screw?
A screw? No, a screw is kind of like the male, right? So you have like a bolt. Like a bolt will look like this, right? And you have like this guy, and you have like threads, right? You guys seen this before?
Is it round?
Yeah, yeah, it's round. It's round. Yeah.
That's not what I meant.
Yeah, it's like a bolt and a screw, you know. Yeah. Okay, and then a nut is kind of the receiving end of this. It's like kind of what mounts on the outside, and it goes over this, right? And goes like this, like this. And as you turn this guy, and screw kind of over here. As you turn, it kind of tightens up against it. Yes, male and female end, right? Yes, and it just kind of pushes up. Make sense? Yeah. You know, I'm making this more. It's just literally a standard screw, and it's a bolt and a nut. That's all it is. Okay, you can buy stuff in Home Depot. Okay, point is, at the bottom over here, right? That's kind of like where the head is. It's like this, right? And then we have like another metal plate under here. Now, why is lefty loosey, righty tighty the opposite? Okay, as you tighten the screw, it's gonna pull on the nut. The nut will come downwards, right? So whenever your nozzle is up here, let's say this is my bed, right? And I have my nozzle here, right? As I tighten to the right, as I tighten, that looks to the right. Let's just go to tighten. As I go to the right, it's pulling down, the screw's kind of threading through, pulling down on the nut, increasing the space between the nozzle and the bed. Does that make sense? So as I go to the right, it's pulling onto the bed downwards, which is really increasing the space between the nozzle and the bed. So tighter means looser up here. So that's why righty-tighty kind of doesn't work. It's the opposite. Okay? This is just the understanding. It'll make sense as you do it more often. But for now, just know that right means loose. That's the opposite of the usual. Just think of that. We do the same thing here. And where those are located are literally up here. You see these guys here? Okay? These you can kind of find. Oh, you can see them.
No.
At the bottom over here, there's little two. And there's one more in the back too, the third one in the back. So in case the steps that this guy is doing is not really like what you want it, you can actually fine tune it from all the way back there. There's three of them. Okay? And now just so you know one thing. This, if the bed looks like this guy, right? It's flat. And they have three screws. If you move one of them, you might want to kind of like, you know, at the end, if all of them are not pleased, you might want to do this process more than once, because think about it. Once you pull one, this guy up here went up. It's one flat surface, a plane. You can't pull in one area without nothing happening to the other one. Okay, it's flat. So you kind of want to do this. So sometimes at the end, like, well, this guy is first tunes the back, then you can kind of fix the front and the other front. So this usually works. But sometimes when you adjust this a little more at the end, it might twist the whole bed. And if the bed, again, the most crucial part that you have to calibrate for a successful print is the bed. That will take time, but once you got it, it will print. If you don't spend time on that, 24 hours you spend printing are going to be pointless. Okay? I promise. Been down that rabbit hole. Okay. So this is kind of already pre-done from before. I can just fine tune it a little bit. And even me until today, every time I go out, I got to pause. Wait a minute. If I'm on the top, you know, I got to right or left. You know, you need some thinking. And you want to feel the same amount of pressure. Okay? Same thing. Once you're done, you click over, come over to the other end. Okay, it's a little looser. So I'm going to go. It takes me every time. I've been doing this for years, every single time. There's the red thing. Okay, so once you're done, it walks you through that whole step. It says like, okay, we're going to do this one more time. You click OK. It goes all the way to the back again. This is kind of to double check. Okay, you see now the whole thing. Usually what I think happens, I guess when I clicked it, it went down, because now it feels a little looser than it should be. But what I like to do is I tune it from down here. I kind of fine tune it. So okay. Now I go on, this is the last step. Sorry. Okay, this kind of feels good. Let's go over here. This guy need a little bit more. So I'm going to go to the okay, right about there. Okay. Once that's done, you click done. put this back somewhere. I usually will leave a paper, you know, try not to waste too much paper. Now it's leveled. Next thing we usually want to check for, is the filament, okay? The biggest, most common issue when the printer starts printing but nothing comes out is that the nozzle is clogged. There's nothing going to be on it. The hot end. The most common problem that can happen with the hot end, or as we say, is the nozzle, which kind of looks like this. This is, by the way, what I'm drawing right now. Keep drawing this, assuming this right here is the little brass piece that you guys see on top of here that I say you should never ever touch. That little guy, see how small it is? Can you guys see it? Yeah? If you need to get closer, that's okay. It's kind of right here. Is it black because there's filament on it sometimes? No, it's kind of color black. Yeah? Can you guys see that little piece? Yeah. That's what I keep drawing in there. Okay, it's kind of covered with a little piece of sheet metal stuff that we have in the front, or the machined aluminum. No, sheet metal. Okay. Okay, and this is kind of what it looks like. But it has like a little extra gap from where it actually kind of heats up. It has like a heating element. It's like a little block that this threads into. This guy threads into this, so it looks like this. This threads on the inside, and this is like kind of like a block in here, an aluminum block. And there's like a little rod that heats up. That heats up this whole aluminum piece, which heats up the nozzle. As the filament goes through here, it already starts melting, and it builds up inside of here, and then it kind of spools out, okay, as you walk it through. Okay, because it's kind of gravity fed. Okay, it will also, you know, it's not only gravity fed because the film is being pushed in, so the more stuff you push in, the more melts, and more stuff is going in. It's hard up here, so it's clogged. You know, you can't not go through. So as you push this through, it's kind of pushing the molten stuff in, right? And that's how you starts building layer by layer on your prints. However, sometimes stuff gets to these corners, right? Like it's not very hot. Okay, so sometimes over here in these little corners, and it solidifies. It gets stuck. Okay, and it's enough for it to sometimes block, completely block, maybe up here a little bit, completely block the filament from going through. Okay, usually not down here. It's usually kind of up here. It blocks, that kind of builds this little wall, and it stops the filament from going through. And that's called, it's a clog. And that's very common. It will happen a lot, okay? And the way to deal with that is you actually have to like remove, I'm gonna walk you guys through how to do that. That's the last step before it gets going. Okay, let's just do that. Let's just remove it. I'm gonna show you how to change filament, okay? Let me just do that, and then as I do that, I'm gonna show you this. Just know that the most common problem, whenever stuff doesn't come out, is because it's clogged. Makes sense, right? Nothing's going through, something's stopping it. How do you get rid of that clog? Multiple ways. First way, you just manually control how hot that gets and increase it to the max. It'll just melt everything in there, right? Another way, if that doesn't work, you get a piece of like a rod or something. They sell them actually. They sell them like 0.4 millimeter diameter brass rods or whatever, and you just push it all the way through from the top till it comes out of the front. I usually just take another piece of filament and just push it through until stuff comes out. Good. Okay, so we're gonna go under material. Okay, we're gonna click on material, which is the other option next to prints. Material. Click on material. We're gonna click on change. Okay, I'm gonna click on change. Just gotta go back to 0 on this end over here. The bed doesn't really necessarily need to come up. Then it goes to the front for ease because usually you will be working here. Okay. Every time it does anything, it will always go back to 0 to know where it is. So for you to switch to material, it remembers from the last time that when you start printing, the material stayed right there, right? Or kind of sort of right here. So if you try to pull on it right now, nothing will come out. It won't come up. Okay. The way to open this, by the way, there's like the top of this piece. Let's see. The top of this piece kind of looks like this. This is like the black plastic, right? The big bulky part. We all see it right there. This guy right here. Can we all see it? Yes? This guy right there? Okay. So that is kind of divided in half. It's not really like solid on the inside, except for like it has 2 little slots. Let me drill them. Hopefully you guys understand what I mean. Okay. doing now, it took the stepper motor just went reverse and took the filament all the way out after you heated the front. And why it did that is because, remember, like it's solidified on the inside, so it melted that so it can pull out. Had you tried to pull it out, it wouldn't have worked because it's solidified on the inside. Okay? But there's a little tube, like a little white piece of plastic that looks like this. You guys understand that what I mean by a dot is like a hole, right? You guys get that? Okay. So you have to push. There's a little, also like E tube. Right here. This. And it's kind of like cylindrical, you know. Well, actually, there will be a wall here. It'll look like a straight wall. Anyway, you guys get what I mean. And it looks like this. So when the filament goes in, and there's like a little tube on the outside, right? This little white tube. Okay, this tube right here. This is a PTFE tube, I believe it's called. You need to know that. But what you do need to know is every time you want to change the material, you have to push the white plastic down. It looks like it's right on it. It looks like you have to pull it up. You see this little white plastic right here? Like I can see previously somebody tried to pull it up. That's why it's broken from one side. It's right on it. But it's like a press fit type thing. So if I push it down, see if I try to pull, nothing is coming up. But once I push the white plastic down, and shake it a little bit, that's how it comes up. So it's right on it. You see how this little white plastic right there? It's right on it. And it's intuitive for you to pull on it. You actually have to push down on it, okay? That's important to know. It's counterintuitive. Once you pull that up, okay, usually the only reason I do that is whenever like stuff gets stuck in the middle of here, but also sometimes when I feed the material through, the material kind of comes in curved, you know, because it's spool, so that like naturally it kind of looks curved. So sometimes it gets clogged on the edges. So I kind of manually make sure I feed it. I'll show you guys.
The first time? Like in the
Yeah, only the first time. Only the first time. So back here, took all the way to film it out. I'm going to reuse the same filament, just so you know. You can just pull on this guy all the way out. Okay. This is the filament. That's all it is. You can see the teeth biting on the edge right here. You can kind of see that. The way you tell if filament is good or bad, grab it and twist it. If it doesn't snap, if it's not hard and brittle, you guys know what brittle means? Shock. Like shock is brittle. It snaps. If it's like mushy and it takes a while for you to rip it, that means it's good filament. Okay? You never want to have the filament by the sun or in the window. Okay? You never want to have it on the sun. Okay? You never want to have it outdoors. You always want it in a concealed cabinet. That's why they come into these little, whenever you order them, they come into like these sealed bags. You don't want any UV lights on them. You don't want them in the heat. You want it in a cool room. Okay? Otherwise, brand new material will go bad. Okay? And it'll be brittle. I believe the red one is bad material. I think that's why I brought it. I think so. So the moment I snap, oh, actually it's still good. Okay, but you see how it kind of took a few snaps and then went right out? Usually if you hear the snap right away, it's really bad. This might still be workable. But you see how it only took a few times? That one took me a lot longer. Once you're done,
Is that PETG?
No, it's ABS.
Oh, because it was...
It's the same red, yeah. Yeah. No, it's not. I think I left it in the room. We do have some BTG. So this guy, just pulling through here, you feed it in and out, okay? Once you feed it in, just push it in, okay? And just kind of, whenever you're ready, actually, you're just gonna let it know. So you click, okay, continue, I'm ready, and it starts gonna roll, it's gonna roll the little feeder slowly. You say ready? You're gonna select what type of material. Based on what type of material, it will know which type of heat to work with from now on. We're working with PLA, so click on PLA. So now, can you hear it? It's just feeding very slowly. This one, it wants to help you kind of feed this little, it's like a little insert back here. From under here, you guys see that little silver insert? Can you guys see that? Like a little silver insert? Yeah, come here, you guys see that? Okay, you want to feed this filament right up that hole, okay? And it'll start on taking it. You have to force it a little bit. There. I already sort of set it like if I pull back, it's not taking anything, okay? It's on it. Once you do that, you click on it one more time. It's going to accelerate it all the way to almost the front. Just feeding it through. Can you see how it's almost right here now? And now start feeding very nice and slowly. Okay? This tube falls all the way in to right where it should go, but sometimes it still fails.
And actually, let's try it. Let's just put it in this and see what happens, if it goes through or not. You should now wait until, oops, okay. You should wait until you see filament coming out of, hear that?
Yeah.
Okay, so what I do is, I gotta just cut it up and do what I told you guys about. I kind of just eyeball it. You can look, if you look at the top, you can kind of see where it's supposed to go. You should not do that. With better printers, we would not deal with that. Okay? Oops. Okay, I'm gonna leave it kind of for a second. You really shouldn't have to do that. There we go. I think I got it. Okay, you see that? Okay, there we go. There was some sort of clog there before. Okay, so we click on ready. And then I'm going to go to settings real quick. Material. Actually, let's go to settings. That can you guys kind of see that as I'm pushing down, stuff is coming up, or no? Can we see that? No, okay. It's heating up. It's at about 190. Usually 190 it begins to solidify. 200 is kind of like just liquid-ish. 210 is kind of like the sweet spot. 220, 110, that's where you want to be. Like it's completely fluid. Okay, can you see, like, as I push down, you see it coming? Can you guys see that? The back is very hard to see.
Yeah.
Very hard to see. But can you see that as I'm pushing down? Sorry. Film is coming down. Can you see that? Like a nice thin film. So I'm just going to push all the way down until this tube is back to where it's supposed to be. Again, with the newer printers, you guys are just going to need to put new filament, put it right from the back, and you're done. This is just, it's kind of an old printer that's been here for a while. Okay, pretty much done. Okay, so this kind of cuts it. So you see how the spaghetti is on gravity? This is kind of what it would look like usually. It's got a lot of it, like a lot more than that. Okay, so now that this is done, we have that done. We have it calibrated. Let me put the SD card in, and let's go to print the what's called a calibration cube. So when you guys export stuff, by the way, I never covered that over here. We have the raft. Okay, now look at this raft over here. I'm going to go all the way down to the very first layer, okay? Here. And now I'm going to try to go into here and put down to open right hand side. Okay, so you see how I just built one straight layer right there? I go to layer number 2. Layer number 2. Yeah, it's another one kind of like 45 degrees, sort of like okay, it's kind of going this way. And then another one, it just adds a little more. Right, and you can control how many you get. Okay, then 4, just one more, kind of sandwiching it in the middle. And then 5, I guess one more, go up to 7.
No, 5
okay,
is
now,
actually
sorry, there you go. Now it's starting to build the actual thing. Okay, so 4, start building of course with the outside structures. Okay, so once you're done with your file, you usually have an SD card. Okay, right on it, because that's what goes into the printer. SD card. You can plug a USB usually if you want an SD card, and you guys just click save to file. Okay. Usually when you plug in the SD card, does this one have yeah, it does. Look, so I plug it into here, right? It should say save to SD immediately. Okay, and by the way, oh there we go. You see, it's saved to removable disk. Yeah, removable drive. So usually recognizes it's there. Is an SD card, this way it's 4, so it automatically saves to it. Okay? And you can also calculate costs. You see how it says grams? You can say, okay, I charge a nickel per gram, and then you can put in the math, and it actually tells you, okay, this print will cost this much. Okay, you can calculate that. Once that's done, you plug it right into here, and you go straight to what it says print, which is the very first option. Once you go into there, it says reading card. It saves per order based on time. So the last file under this list is the newest item you uploaded. Okay, it's not alphabetical or anything like that. So you can just go up if you have a lot of stuff like us over here, and it'll take you to the very last file. Okay, I'm gonna look for calibration cube. I'm gonna have that going. Now remember, this printer did have problems. So XYZ calibration, there we go. So now it's just heating up the bed to 60 degrees. This already preheated to where we need it to. So, and I can actually see what's going on where it says tune. If I go into tune, I can see all the options. I would just scroll through. I can control also, like if you're printing at night and you don't want like too much lighting and stuff, you can kind of reduce the light. You know, you can almost take it out if you want to. It's just, I just always leave it 100%. It looks cool. That's it. There's really not much else to it. You have speed, feed rate, heat, all this extra stuff. That's a whole. We'll talk about that stuff in detail later. Right now, just heating up. What a calibration cube is this guy. It has X, Y, and Z on it. Okay. I think I tried to destroy it once to show someone else before that it's durable in one direction. You can almost step on this from the top, but the moment you do that from the side, since it's hatching, there's almost no side wall structure. But you can almost step on this from the top. Okay. Yeah. So this extra guy right here. A lot of you guys know what is this guy. Okay. You don't always have to model stuff. Okay. This is a scanner. You put like a little item right in the middle of this platform over here. This is like this. It's not that big, and this takes a long while. It just scans layer by layer, and it builds this little item that you put in the middle. You can put this little marker in the middle. You can put whatever you want, and it will scan it. It'll kind of go do one of these, and the camera kind of it'll kind of rotate together. Okay, it's like an angular. It's like a different type of scanners. There's a lot. So at the print, okay, it's something wrong here. I can see there's something a little bit wrong. All right. So it just extrudes a whole bunch just to let you know, okay, it's extruding, it's fine, right? Now it's extruding much slower, and it's something going on. Oh, I forgot to put the glue. It's not sticking.
Man.
There you go, I'm fired. I'm like, whoa, the line's not sticking. Okay. So you see, it's kind of still trying to do it. Almost successful at it. Now it's kind of like melting it down, but I needed glue. The moment it went down, it just picked right up to the corner. Okay, the glue stick. Okay, that's what I need to put. All right, I'm gonna walk out of here. I'm fired. Okay, yeah. So glue stick, evidence why you need it. Okay, the moment it went, it'll fix itself. Sometimes if it starts failing at the beginning, you want to leave it a little bit. It kind of fixes itself over time. Yeah, it's gonna be a failed print. It's not sticking. Okay. Now let's try this. Let's do tune, abort. Yes. Okay. Nothing is sticking. It's not filling it up. This wasn't going to be a good print at all. Okay. That's how important it is to adhesion to the build plate. Okay. Yeah, that's how some of the prints also like this has support on the bottom. You can see the bottom of this hand looks very nasty. You can see that the edges kind of look okay, but a lot of it looks kind of nasty because, again, supports kind of leave this look to it. Okay, and these, by the way, were printed individually in separate parts. Okay.
In the 3D printers in December, did you have to put glue on the actual base or?
Over there, no. Those are like higher quality
high
stuff.
quality.
Yeah. Yeah, those are like higher quality stuff. And what actually it does every time it builds a raft. That kind of works as the adhesion itself.
Oh, okay.
Every time it always builds a raft. Yeah. So yeah, we should add glue. But let me just kind of show you this thing real quick. What you can do also deform stuff. So let's say you want to make like a bracelet, but round stuff is kind of nasty to print, right? Like I brought a little extra piece with me. One last thing I want to show you guys. Like this piece right here, right? This is kind of what's on the hand down here. You see how it's kind of curved? The printer would have struggled to do this. Okay, this would have been easy at all. And you see how it's perfectly flat around those screws? What we did is we kind of mounted it on it first, put the screws in, and then we just heated it up right here. And then we manually, it was hot enough that it didn't melt, but it was, it was flexible.
Malleable.
It
was malleable.
Yeah, it was malleable. And I guess that's a good term. And you can shape it, you can stretch it, you can shape it. Sometimes you can work, like if you want to add like a little lens in the middle or whatever, you can make it kind of sort of up to tolerance, and then you just heat it up, squeeze it in, and you push it back in so it holds it in. There's a lot of cool stuff you can do. You need a heat gun for that. And acetone, like for ABS, to have like a nice solid finish on the outside, like a nice glossy finish to the outside. there's all these separate stuff to do. Any questions so far? Yeah? That last part that I just mentioned about this and the ABS, this is kind of a post-processing part that I mentioned at the beginning. So CAD is different softwares, looking to Fusion 360 for that. 3D slicing, okay, after CAD, there's libraries you can access. That will load the STL file. Remember, that's the file extension we need, is an STL file. And once you download that, you bring it to the slicer. Slicer is this guy. We spoke about all the different stuff we got to need into. Layer heights and infill is what the main two things that control time. Okay, those are the main two grand things control time. What controls quality is the layer heights. The smaller the layer heights, the higher the quality, the longer the time. Okay, kind of makes sense? Brims are used for adhesion. Okay, the brim kind of is for adhesion. So wraps are also for adhesion, but brims specifically are for adhesion. The bed leveling, when you're leveling the bed, is the most important part of the 3D print. If you don't level the bed right, you're going to have it very off print as well. And if, let's say, sometimes you did everything right, and you did everything right, you got to update the software every now and then. This guy is almost up for updating the firmware, sorry, not software, the firmware on this guy. Okay, sometimes that's a little wire to start just making weird stuff that doesn't make any sense. Update the firmware. Usually solves a few bugs. Okay, it kind of covers the post-processing. That's the whole chapter in itself. Just know there's a lot of cool stuff you can do after you 3D print. It's not just 3D printing. Does that kind of cover it? Yes? No? Maybe? Any questions? Okay.